Why? Let's see here. So I'm back again. This is the stack-based virtual machine, and I, along with a coworker of mine, we have debugged this, and it works. Anyway, so yeah, this stack machine works. Basically, I was running into the problem where I had, if you look here, let me go over here. If you look over here, I have the I had the program counter starting at 0, and then I had a stack pointer starting at 0. And the problem is that the whole point of a stack machine is that you have stack. So basically, this stuff over here is program memory. That's separate. So the way this machine works is it has, well, I can't use the word heap really. It has a set amount of memory, 0 to whatever number. From 0 to 64, it is stack. You don't load a program to this part. This is stack. This is just for the virtual machine, as if it had 64 registers, but it's 64 parts of memory. One moment. Hello. Anyway, so the first, sorry, I'm just getting stuff on my phone here. Anyway, so the first, I can't take this seriously. The first part of the machine is stack, 64, in this case 64 bytes. Stack S, that's what the, right here, stack S is 64 bytes. Then, after the stack, you have your program memory. I have 256 bytes. This is where you copy your program into, okay? Then, after program, I have heap, but I don't use that because I don't need to yet, but maybe further down the line. So the whole way this machine works is if you come down to oh my god, okay, that's do permit. There should be a decode function. No, here we go. Execute. If you look at execute, one second, sorry. Anyway, if you go down to execute, right here, it says if lookvm type equals 0 or 2. So that's basically if it's a number. If you're running into a number, positive or negative, then what it says is increment stack and then put that number into stack. So the only thing you're putting into stack is bare numbers. You're not, whenever you see an instruction, that's something the program does. If you see just a bare number, that's something that gets put into stack. Okay? So stack and program memory are completely separate. You can copy one to the other, but you can't, well, as far as I have, you can't run from stack. That's the whole point of stack, right? Well, I'll take that back. That's not quite true. Anyway, so it's working now. The instructions I have is halt, right? Stops the machine. Add, it adds the number at stack pointer and the one right behind it, and then puts that result at stack pointer -1. Subtract is the same thing, only subtracts. Increment, decrement, basically it takes what's at stack pointer, what the stack pointer is pointing to, and just increments that value by 1. And decrement subtracts it by 1, that sort of thing. ISP, DSP, that's for increment stack pointer, and decrement stack pointer. I'm running into the problem where I don't know enough. I don't know enough about computers. I don't know enough about CPUs and microcode to know the most efficient instruction. So what ISP and DSP does is it takes your stack pointer and just moves it up and down the stack. Originally, I had something called pop that popped off the top of the stack. It just moved the stack pointer down. But then I realized that's not quite true. Not quite what you want. You want pop will pop to a register or something. That's not what it does. I just wanted to move up and down the stack. I'm not sure if those are the right instructions. Maybe there's a better instruction for that. Then you have BEZ, branch if equal to 0. Basically, the way I have this set up is if you, let me see, so don't say something stupid. Okay, check this out. So let's test it out. If I have 0, 0, okay, and change this to BEZ, so what's going to happen? BEZ is branch if equal to 0. So remember, we have just now essentially copied these 4 numbers to stack. Then it says BEZ. If this number, the number from the top of stack minus 1, is equal to 0, increment the program counter by this much. So basically, you branch by that amount. Because I don't want to, it to do anything like crazy, I have it incrementing by 0 right now. See, it works. It halts, right? So basically what's happening is it's just moving on to the halt instruction. Now, if I did this, if I had a no op in here, or code that I just didn't want to run, like say I had an add instruction, right? But if this is 0, I didn't want to run that. I could just do that. Oh my god. Basically, what's happened here is if this is equal to 0, increment program counter by this much. So basically, I have now skipped over this instruction. And, you know, if I had a sub instruction here and I wanted to skip over that, I could do 2. But say I want to do this. If this number is 0 right here, then, and if I want to just subtract, if this number is 0, I can have a 0. I can have a 1, right? Skip over the add instruction and just do the sub. If this is not true, it will do both add and sub. As you can see here, there is add and sub, just as I said. But if we change this to a 0, then we should just see a sub. And if you look, there is only a sub. Oh Lord. What's up? How's it going? Okay. Yeah, I still have no real clue how OBS really works. what else do we need to show increment? I mean, so basically here I can do this. I can, let's say 3, 4, 5, 6, right? And then let's get rid of the BEZ. Let's do DSP, right? Move down the stack. Right, so 2, 3, 4, 5, 6, and then DSP move down the stack. And then if I do this again, 3 times, I should move down the stack 3 times. Yes, I'm back down to 0 because what happened is it goes 3, 4, 5, 6. DSP is now 5, DSP is now 4, DSP is now 3. What else? If you increment, I have no check for incrementing or moving off the stack. That's just, why would I? That's like, that's a lot of, there's no reason to. At least there shouldn't be any reason to. It's not like it's a physical hardware limitation. Basically, you just crash the program. Branch if equal, I think it's Turing complete right now. I'm not sure. I don't know how to tell. The 5 instruction set computer is Turing complete, the one I made, or the one I emulated. It has increment, decrement, check if 0, and then jump. The thing though is that I have a branch of 0 with an arbitrary number, so I think it's Turing complete. Yeah, I think it's done. I think it's ready to try to port to the CPM machine. I don't have a cable to stream that really, at least well, so I have to figure that out soon. Oh my god, what time is it? Ugh. It's 11 o'clock, my dudes. Jesus. Well, I am headed off to bed. After I port this over to CPM, I think I'll start on a register-based CPU machine. That would be pretty interesting. That'd be pretty fun to do. So I could emulate like CPU on an Altair. That'd be pretty awesome. Anyway, that should be it. Good night, and I'll see you in the next one.